arranged and thus form a network-like structure. The distribution of matter in the universe is not homogeneous, but structured by the cosmic network. Dark matter plays a crucial role in the formation and maintenance of the cosmic web. Filaments are huge thread-like structures that connect the galaxy clusters in the universe. They consist mainly of dark matter, gas and galaxies. The gravitational force of dark matter plays a crucial role in the formation and maintenance of these cosmic structures. Filaments serve as a highway on which galaxies migrate towards the denser galaxy clusters. Voids are huge regions of the universe that contain extremely few or no galaxies. These voids make up a significant portion of the volume of the universe. The formation of voids is influenced by the gravitational effect of dark matter and the expansion of the universe. A galaxy cluster is a collection of hundreds to thousands of galaxies. Clusters of galaxies are the largest known structures in the universe held together by gravity. Studying galaxy clusters helps to understand the distribution of dark matter and the evolution of the universe. A supercluster is a large collection of galaxy clusters that are bound together by gravity. Supercluster are the largest known structures in the universe. The gravitational forces within a supercluster influence the motion and evolution of the individual galaxy clusters. The Great Wall is one of the largest known structures in the universe. Its extent exceeds imagination and stretches over unimaginable cosmic distances. The structure consists of complex interconnected energy pathways and cosmic elements. Their formation and function remain one of the greatest mysteries of cosmology. The dipole repeller is a cosmic region that repels galaxies. The repulsion is caused by the gravitational effect of a region of low density. The dipole repeller influences the motion of the local group, which includes our Milky Way. The Shapley concentrate is one of the largest known clusters of galaxies in the observable universe. Studying the Shapley concentrate helps astronomers better understand the large-scale structure of the universe. The local supercluster, to which our Milky Way belongs, is a huge collection of groups of galaxies. This structure spans hundreds of millions of light-years and contains thousands of galaxies. Gravity holds the local supercluster together and affects the motion of the galaxies contained within. Located in its cosmic neighborhood as one of the largest known galaxy clusters, the strangulation cluster contains thousands of galaxies. The gravitational pull of the choke cluster influences the motion and evolution of galaxies around it. The Milky Way is a barred spiral galaxy that contains our solar system. It is made up of billions of stars, gas and dust held together by gravity. Our solar system is located in one of the spiral arms. Far from the galactic center, the solar system consists of the Sun and all the objects that orbit it. The gravitational force of the Sun keeps all planets and other celestial bodies in their respective orbits. The main components of the solar system include the Sun, 8 planets, dwarf planets, moons, asteroids, and comets. The planets of the solar system can be divided into inner rocky planets and outer gaseous planets, the Earth a blue planet. Am I floating in dark space, surrounded by a thin atmosphere? Continents and oceans make up the Earth's diverse surface. The atmosphere protects the Earth from harmful radiation and enables life. The Moon, the only natural satellite of the Earth, is a rocky body without an atmosphere. Its surface is marked by countless craters created by asteroid impacts. The Moon influences the tides on the Earth and stabilizes the Earth's axis. Mars, also known as the Red Planet, is the 4th planet from the Sun. Its surface is characterized by huge volcanoes, deep valleys, and vast deserts. Mars' thin atmosphere is composed mainly of carbon dioxide. There is evidence of previous liquid water on Mars, raising the possibility of past life. Jupiter is the largest planet in our solar system, known for its distinctive cloud bands and the Great Red Spot. Jupiter's cloud bands are formed by strong winds and convection currents in its atmosphere. The Great Red Spot is a gigantic, persistent storm larger than Earth. Jupiter consists mainly of hydrogen and helium, similar to the Sun. Jupiter has a strong magnetic field that extends far into space and affects its surroundings. Saturn is known for its distinctive ring system, which consists mainly of ice particles, boulders, and dust. Saturn's rings are divided into different regions characterized by gaps and different densities. Saturn is a gas giant composed mainly of hydrogen and helium and has a low density. Uranus is the seventh planet from the Sun and is distinguished by its pale blue color. A peculiarity of Uranus is its extreme axial tilt, which makes it appear almost lying on its side. Uranus has a ring system, but it is less pronounced than Saturn. The atmosphere of Uranus consists mainly of hydrogen, helium, and methane, with methane being responsible for the blue color. Neptune is the outermost planet of our solar system. Is an icy giant with a fascinating blue atmosphere. Its strongest winds in the solar system race at speeds of over 2 kilometers per hour around the planet. Neptune owns a faint ring system and several moons, including Triton, the largest of Pluto. Once considered the ninth planet of our solar system, it is now classified as a dwarf planet. Pluto's unusual orbit and small size led to its reclassification as a dwarf planet I in 2006. Pluto has 5 known moons: Charon-Styx, Nix-Kerberos, and Hydra. NASA's New Horizons mission provided detailed images and data about Pluto's surface and atmosphere. Asteroids are small, rocky celestial bodies found mainly in the asteroid belt between Mars and Jupiter. Their size varies from a few meters to several hundred kilometers in diameter. Asteroids consist mainly of rocks, metals, and ice. Some asteroids cross the Earth's orbit and thus pose a potential impact risk. Comets are small celestial bodies. They move in elliptical orbits around the Sun. The composition of a comet consists mainly of ice, dust, and frozen gases. When heated by the Sun, the volatile components sublimate and form a coma and tail. The tail of a comet consists of dust and ionized gas carried away by the solar wind. These objects, including dwarf planets like Pluto, are remnants from the formation of the solar system. The Kuiper belt extends from about 30 to 55 astronomical units (AU) from the Sun. Compared to the asteroid belt between Mars and Jupiter, the Kuiper belt is much larger and more massive. The Oort cloud is a hypothetical spherical cloud of icy chunks that surrounds the solar system at a great distance. It is believed to be the origin of many long-period comets that approach the Sun. The Oort cloud is thought to extend to a distance of nearly 1 light-year from the Sun, its existence indirectly inferred from observations of comet orbits and frequencies. Exoplanets are planets orbiting other stars outside our solar system. The discovery of exoplanets has expanded our understanding of the diversity of planetary systems. The search for exoplanets often focuses on the habitable zone, where liquid water could exist. Methods for detecting exoplanets include the transit method and the radial velocity method. The habitable zone is the area around a star in which the temperature allows the existence of liquid water on the surface of a planet. The position and width of the habitable zone depends on the luminosity and temperature of the star. Liquid water is a crucial prerequisite for the formation and maintenance of life. As we know, planets within the habitable zone are primary targets in the search for extraterrestrial life. The search for extraterrestrial life encompasses various scientific disciplines and technologies. Radio telescopes play a central role in receiving potential signals of intelligent life. Bowie at the universe. Analyzing exoplanets for livability is an important step in the search for habitable worlds. Finding biomarkers in the atmosphere of exoplanets may provide evidence of biological activity. The SETI project searches for extraterrestrial life by listening to radio signals from space, analyzing the received signals aiming to detect patterns that indicate intelligent extraterrestrial civilizations. The SETI project uses huge networks of radio telescopes to scan the entire sky for potential signals that ask the Fermi paradox: why, despite the high probability of extraterrestrial life, we have not found evidence of it. One possible explanation is that technologically advanced civilizations pass through a kind of grand filter that ends their existence. This great filter could be a natural disaster, self-inflicted destruction, or a technological singularity. The Fermi paradox stimulates thinking about the future of humanity and the risks of technological progress. Space travel visualizes the movement of spacecraft through space.
Different propulsion technologies enable different speeds and ranges in space travel. Navigation in space requires precise calculations and the consideration of gravitational forces. Communication with spacecraft takes place via radio waves and requires sophisticated antenna systems. Space stations are artificial structures designed for longer stays in space. They serve as research platforms, observation centers, and potential starting points for further space missions. Space stations consist of several modules that are assembled in orbit. Solar panels convert sunlight into electrical energy to power the space station. Space probes are unmanned spacecraft used to explore outer space. They collect data about planets, moons, asteroids, and other celestial bodies. The collected data is transmitted to Earth to expand our understanding of the universe. Space probes allow exploration of distant places, which are unattainable for manned missions. Telescopes are sophisticated instruments that allow us to observe distant objects in space. They collect and focus electromagnetic radiation to produce detailed images and data of celestial bodies. Different types of telescopes are optimized for different wavelengths of the electromagnetic spectrum. By analyzing this radiation, astronomers can determine the composition, temperature, and motion of objects in the universe. The James Webb Space Telescope is a state-of-the-art observatory designed to observe the universe at infrared wavelengths. Its main task is to capture the light of the first stars and galaxies after the Big Bang. The telescope uses a large mirror and infrared sensors to see through clouds of dust and track down hidden objects. The James Webb Space Telescope allows scientists to study the formation of galaxies, stars, and planetary systems. Gravitational waves are ripples in spacetime, which are generated by accelerating masses. The strength of a gravitational wave decreases with increasing distance from its source. Gravitational waves propagate at the speed of light and can travel through the universe without being significantly absorbed. The detection of gravitational waves confirms Einstein's general theory of relativity. Merging black holes and neutron stars are the main sources of detectable gravitational waves at the Laser Interferometer Gravitational Wave Observatory. LIGO is used to detect gravitational waves. LIGO measures tiny changes in spacetime caused by gravitational waves. Interferometry is used to detect the smallest changes in length. The detection of gravitational waves confirms Einstein's theory of general relativity. The Virgo Observatory is a sophisticated facility for observing gravitational waves. It uses laser interferometry to measure tiny changes in spacetime caused by gravitational waves. Gravitational waves are produced by accelerated masses, such as in the collision of black holes or neutron stars. The detection of gravitational waves makes it possible to observe the universe in a new way and study astrophysical phenomena. Future technologies allow detailed exploration of space. Advanced sensors and instruments provide precise data on distant celestial bodies. Autonomous systems and artificial intelligence control complex space missions. Innovative propulsion technologies enable faster and more efficient journeys to distant destinations. Interstellar space encompasses the vast regions between stellar systems. It consists mainly of extremely diluted plasma, gas, and dust. Interstellar space is not empty, but is permeated by a complex network of magnetic fields. These fields affect the movement of charged particles and the propagation of cosmic rays.